Hello, dear students. In this class, we are going to discuss a probability case study. This case study is little tricky kind of question. Okay, let's go through this question. Arka bought 2 cages of birds. Cage 1 contains 5 parrots, 1 vole. Cage 2 contains 6 parrots. One day, Arka forgot to lock the both cages. 2 birds flew from cage 1 to cage 2, cage 2 to cage 1. So, assuming that the all birds have equal chance of flying. So, on the basis of above information, answer the following question. When 2 birds flew from cage 1 to cage 2 and 2 birds flew back from cage 2 to cage 1, find the probability that all is still in the cage 1. Let us say E1 is the event. Let us say E1 is the event of one parrot, one event of one parrot and one owl flew from cage 1. Okay, this is cage 1. Let us say E2 is the event of 2 parrots flew from cage 1, and here he is saying here probability that all is still in the cage 1 is saying. So let us say E is the event of all is still in cage 1. Now let me explain this. In cage 1, 5 parrots, 1 owl. Okay, so this is cage 1, 5 parrots, 1 owl. Okay, so owl. And here in cage 2, 6 parrots are 6 parrots we have. 6 parrots. So this is cage 1. This is cage 2. Now 2 birds flew from cage 1 to cage 2. Now let us say first 2 birds. So here let us say here 2 birds means one is parrot, one is owl we can consider. Okay, one is parrot, one is owl, and it came back, flew back. Okay, the same, one parrot, one owl. Okay, the same way here one parrot and one owl flew from cage 1 to cage 2, and from cage 2 it came back only 2 parrots but not one owl. Okay, wall. Okay, so one more case is 2 parrots went and came back 2 parrots from cage 2. So these are the possible 3 cases we have. Okay, now E1 is what? 1 parrot and 1 owl flew from cage 1. E2 is the event of 2 parrots flew from cage 1. Okay, these are the 2 events we have, and A is the owl is still in cage 1. Okay, so we need owl is in still cage 1 only, in which case cage 1 owl should stay. Okay, let us say here in first case one parrot and one owl goes to cage 2. Okay, from there again it will came back one parrot, one owl. Okay, now let us say here total probability cases, total number of outcomes. So total number of outcomes, let us say 5 parrots we have, 1 owl. So out of 5 parrots, 1 parrot went. So we selected 1, and out of 1 owl, one selected 1 owl. So it went. Okay, it went to cage 1, cage 2. From cage 1 to cage 2. In the cage 2, again 1 parrot went. So 1 parrot plus 6 parrot, 7 parrots and 1 owl, right? So from cage 2 to cage 1, once again it flew back. So 7 parrots, out of 7 parrots 1 parrot, and out of 1 owl 1 owl. It went back. This is the first case plus second case, 2 parrots went. So we have 5 parrots. Out of 5 parrots, or plus means or, okay, or 5 parrots, we have to select 2 parrots. So out of 5 parrots, 2 parrots flew from cage 1 to cage 2. Again, if it is flew from cage 1 to cage 2, then if 5 parrots, out of 5 parrots, 2 parrots flew from cage 1 to cage 2, 6 plus 2, 8 parrots, right? 8 parrots. Out of 8 parrots, again 2 parrots flew from cage 2 to cage 1. Let us say how many out of 8? 2 selected. So this is case 2. Next, case 3 is what? Case 3, which is nothing but E1 only. Okay. So here 5 parrots. Out of 5 parrots, 1 parrot went, and out of one owl went, and while returning back from cage 2 to cage 1, 2 parrots it came, right? 2 parrots. So let us say 1 parrot it went, then this 7 parrots remains, right? 7 parrots, say you have to select 1 parrot into 1 parrot into, no, just 2 parrots are going, right? We have to select 2 parrots, that's it. There is no owl in this case, right? This is 3 cases possible. Now let us find the total outcomes. 5C1, always remember NC1 is always N, okay? So N, so here 5C1 is 5 into N, 1C1 is 1 into 7C1 is 7 plus 5C2, write 5 descending order 2 numbers, 5 into 4 divided by 2 into 1 into 8, right, descending order 8 into 7 divided by 2 into 1 plus this is 5C1, which is 5 into 7C2, 7 into 6 divided by 2 into 1. So from here 5 sevens are 35 plus here 2 twos are 4, 5 eights are 40, 40 into 7. So here what is asking the question, when 2 birds flew from cage 1 to cage 2 and 2 birds flew back from cage 2 to cage 1, then find the probability that the owl is still in cage 1. So he's saying owl is still in cage 1. So probability of A is asking, okay. So let us say probability of total. So here probability of A is asking, according to the total probability theorem, P of E1 into P of A by E1 plus P of E2 into P of A by E2. This is the total probability theorem, right? Now let us consider here P of A by E1 conditional probability, then P of A intersection E1 divided by P of E1 is a formula, right? Send this term to the left side. So how we can write this? P of A intersection E1 is equals to P of E1 into P of A by E1. So in the place of P of E1 into P of A by E1, can I write P of A intersection E1? So I'll write this. So P of A intersection E1 plus P of A intersection E2. So E1 is 1 parrot, 1 parrot and 1 owl flew from cage 1, right? E2 is the event of 2 parrots flew from cage 1. Okay, so here now look at here, 1 parrot, 1 owl, okay? 1 parrot, 1 owl flew from cage 1. Again it came back to the cage 1, right? It came back to the cage 1. So owl still in cage 1 only, right? So in this case owl is in cage 1. And next in this case 2 parrots flew from cage 1 to cage 2 and from cage 2 to cage 1. So 2 parrots went and came, okay? So in this case also owl stays here. In this case, third case is what? 1 parrot, 1 owl went, but while returning 2 parrots came back. two parrots came back, one owl stays in case 2. So in this third case there is no owl, right? Owl came into the cage 1. So only we have to consider these two cases. Okay, these two cases. So case 1 is one parrot, one owl went and came back. So this probability here is favorable cases is here. What is the favorable cases? Probability of here still owl A is what? Owl stays in cage 1, E1 case. E1 is what? One parrot and one owl went. So one parrot, one owl went. From out of 5, we can write this. Okay, first case, favorable case. So 5C1 into 1C1, which is 5 7 35. So answer for the favorable case of E1 and still owl stays here is 35. Okay, so 35 by total number of outcomes. Total number of outcomes is 420. Okay, 420 plus here A is the event of owl stays in cage 1. E2 is the event of two parrots flew from cage 2. Cage 1. Okay. So from cage 1, two parrots flew. Right. Two parrots flew and came back. Then here favorable case of second event. Second event is this one, right? This one. What is this result? This result is 280. Okay. This result is 280. We calculated here. 280, right? So this is 280 divided by total number of outcomes 420. If I add up these two together, 35 plus 280, so this is 315, right? 315 by 420. So here 5 table, 5 6 are 30, 5 3s are 15, here 5 8s are 40, 5 4s are 20, and here 7 tables, 7 9s are 7 1s are 7 2s are. Now this is 3 table, 3 3s are 3 4s are. So therefore this is 3 by 4. 3 by 4 is the probability. This is the solution for given question. Okay, next second question we will see. Okay, when two birds flew from cage 1 to cage 2 and two birds flew back from cage 2 to cage 1, owl is still seen in cage 1. What is the probability that one parrot and one owl flew from cage 1 to cage 2? One parrot and one owl flew from cage 1 to cage 2. So one parrot and one owl is asking. So what is he saying here? Already seen means here event is already occurred. Okay, A event is already occurred. Okay, this is the A event. What is this? Owl is already seen in cage 1, already happened. What is the probability of one parrot and one owl flew from cage 1 to cage 2? That means E1 is asking what is the probability of E1 when already A is up happened. So here second question, what is the probability of E1 when already A is occurred? So according to the Bayes theorem, so P of E1 into P of A by E1 divided by P of E1 into P of A by E1 plus P of E2 into P of A by E2. Okay, so this is P of E1 into P of A by E1. Just now we wrote the form, right? What is this form? P of E1 into P of A by E1, P of A intersection E1, right? So we can write P of A intersection E1 divided by P of A intersection E1 plus P of A intersection E2. Okay, so here P of A intersection E1, we already know P of A intersection E1. So P of A intersection E1 answer is 35 by 420, right? P of A intersection E1 is what? 35 by 420. 35 by 420 whole divided by total conditional probability is what? Total probability theorem. According to total probability theorem, 315 by 420, right? 315 by 420. If 420 get cancelled, 420 get cancelled, then what is the answer here? 35 by 315, right? So here you can cancel here. 5 7s are 35, 5 6 are 30, 5 3s are 15. So here 7 9s are, so answer is 1 by 9. 1 by 9 is the solution. That's all. This is the solution.